Good morning everyone. Today, we are going to discuss the SI unit of velocity, which is the meter per second. We will explore how velocity is a vector quantity, and its related concepts such as motion, distance, displacement, uniform motion, non-uniform motion, speed, average speed, speed with direction and velocity. I'm sure we are all excited to learn more about this important concept. Let's get started. Motion is a natural occurrence that we can observe in our lives on a daily basis. From observing the movement of clouds to the movements of a cricket, motion can be seen all around us. Motion can be described as the change in position of an object over time. Distance moved is the length of the path an object travels, while displacement is the shortest distance between an object's initial position and its final position. To explain this further, if an object begins at its origin O and travels to point C, then stops and goes back to point A and returns to point C, the distance traveled will be 95 kilometers, while the displacement will be 25 kilometers. Motion is divided into two types: uniform motion and non-uniform motion. When a body travels equal distances in equal intervals of time, it is in uniform motion, like when driving at a constant speed. If accelerating or decelerating, the body is in non-uniform motion. Speed is the distance traveled in unit time and can be calculated by the equation st=v, with the SI unit of speed being meter per second, or ms1. Being only a magnitude, speed is a scalar quantity. Average speed is the ratio of the total distance traveled to the total time taken, which is the average of the speed of the body during the entire motion. For example, if the total distance is 100 kilometers and the total time is 2 hours, the average speed is 50 kilometers per hour. An important measure of an object's motion is its rate, which is known as velocity. Velocity is a vector quantity, representing both the magnitude and direction of displacement divided by the amount of time taken. Its average velocity is the result of the ratio of the total displacement to the total time taken, which is the mean of the initial and final velocities. Speed and velocity, both expressed in meters per second, meter per second or ms1, are interchangeable. Acceleration is the rate of change of velocity of a body during non-uniform motion. It is measured by calculating the change in velocity in relation to time and is expressed in the SI unit ms2. It can be either uniform or non-uniform. Uniform acceleration is when the change in velocity is equal in equal intervals of time, and non-uniform acceleration is when it is unequal. Understanding acceleration is important as it affects the rate at which a body can move or slow down, and the ability to calculate it accurately is essential in many areas of science and engineering. Graphical representation of motion displays the movement of an object through distance and time. The distance and time can be plotted on a graph to present the change in the position of the body. For a body moving with uniform speed, the distance-time graph is a straight line. This is due to the object traveling equal distances in equal intervals of time with uniform speed. The equation V equals s2s1, t2 t1, can be used to measure the speed of the object from the distance-time graph. Through the distance-time graph, it is possible to analyze the motion of a body conveniently. This slide shows a distance-time graph of a body moving with non-uniform speed. Analyzing the graph, it is evident that the distance traveled is not in a straight line, which means that the speed of the body is not uniform. It can be concluded that the motion is non-uniform with the body traveling unequal distances in equal intervals of time. Velocity time graphs are a useful tool in representing changes in velocity of a body over time, providing a visual representation of its motion. On such graphs, velocity is plotted on the y-axis and time is plotted on the x-axis. If the velocity of the body remains constant, the graph will be a straight line parallel to the x-axis. We can use a velocity time graph to calculate distance traveled between 2 points A and B by working out the area of the rectangle ABDC, where line AC is the time difference between the 2 points and line BD is the average velocity of the body. This way, we are able to understand concepts of speed, distance and displacement through studying the graph. The relationship between velocity and time is demonstrated by a velocity time graph. A body moving with a uniform acceleration has a velocity time graph consisting of a straight line with an increasing slope, indicating that the velocity increases at an equal rate in equal intervals of time. The area under this graph denotes the distance traveled by the body from point A to point E, represented by the area ABCDE. The distance is equal to the sum of the area of the rectangle ABCD and the area of the triangle AD, as shown in equations 1 and 2. Thus, the velocity time graph can be used to measure the distance traveled, providing insight on the concepts of motion, displacement, speed, and velocity. The graph displays a visual representation of the concept of velocity. If the velocity is constant, the graph will have a constant slope. But if the velocity is not uniform, the graph will show diverse variations. This is because the velocity varies unequally in same unit of time. The x-axis stands for the time taken in seconds and the y-axis is for the velocity in meters per second. As illustrated in the graph, the velocity starts at 0 milliseconds minus 1, grows to a peak value of 20 milliseconds minus 1, indicating that the velocity was continually growing in the defined duration. The kinematic equations provide the basis for the equations of motion, which calculate the velocity, displacement and acceleration of a moving body. The first equation is v equals ut plus et, expressing that the final velocity is equal to the initial velocity plus the acceleration multiplied by the time taken. The second equation is s equals ut plus 1/2 et, showing that the displacement is equal to the initial velocity multiplied by the time plus half the acceleration multiplied by the square of the time taken. The third equation is 2 as equals v2u2, meaning that twice the acceleration multiplied by the displacement is equal to the final velocity squared minus the initial velocity squared. These equations of motion allow us to better understand the behavior of a body in motion. Equation for the velocity-time relation states that the final velocity of an object will be equal to its initial velocity plus the product of its acceleration and time. This is illustrated in a velocity time graph for a body moving with uniform acceleration. Point A marks the initial velocity, indicated by u, and point B marks the final velocity, indicated by v. Point C marks the time interval indicated by t. Perpendicular lines BC and B are drawn from point B to the time and velocity axes respectively. These lines represent initial velocity at O and the final velocity at BC. Line AD is drawn parallel from point A and the equation for velocity-time relation can be derived from the respective values of acceleration, time, initial and final velocity. Therefore, the equation tells us that the final velocity of the object will be equal to its initial velocity plus the product of its acceleration and time. The equation for position-time relation states that the distance traveled by an object in uniform acceleration can be calculated by adding the area of a rectangle and a triangle. This equation enables us to calculate the position of an object that has a uniform acceleration, given its initial velocity, time elapsed, and acceleration. With this equation, we can accurately determine the distance traveled in that time. In the velocity time graph, a body is shown moving with uniform acceleration, from point A to point B. The position-velocity relation equation states that 2s is equal to v squared minus u squared. Here, s is the distance traveled by the body between points A and B, u is the initial velocity of the body at point A, v is the final velocity of the body at point B, and t is the time taken for the body to travel from point A to point B. This equation can be obtained from the area of the trapezoid OABC, since S is equal to the area of the trapezium. Thus, we can easily derive from the graph the distance traveled between 2 points, the initial and final velocities, and the time taken to traverse that distance. Uniform circular motion is a type of motion that occurs when an object moves in a circle at a constant angular velocity. This type of motion is seen in many natural and man-made systems, from planets to roller coasters. The centripetal acceleration in uniform circular motion is always directed towards the center of the circle, and its magnitude can be calculated using the equation A equals v2, r, where v is the velocity and r is the radius. This acceleration is also referred to as the angular acceleration and is necessary in order for an object to remain in uniform circular motion. The audience is thanked for their attention, and a great day is wished to them.